Conducting electricity from fruits. In this experiment, I conducted and measured the electric current that various fruits conducted. The materials I used were 3 oranges, apples, kiwis, lemons, galvanized nails, pennies, a knife, a multimeter, a calculator, and a data table, along with a pencil to record my results. I first rolled the fruits to promote the breaking of the juice bags. Next, I chose the unlucky victim and took the knife to make a slit on the left side of the fruit when stem side up. I then inserted the penny until around half of it was peeping through. This penny served as a cathode. Furthermore, I stabbed or inserted, whichever word is your preference, the galvanized or zinc-coated nail until it was around 3/4 the way in the fruit. This galvanized nail serves as an anode in the experiment. I turned on the multimeter to the 20 mark on the DCV side. Using the red probe, I sticked it on the copper side and the black probe on the zinc side. I'm again repeating these steps with the apple, the kiwi, and the lemon, and recording my results as I go along. Whipping out my calculator, I calculate the averages of my data, and of course record them in the process. This is my data. Shockingly, the apple produced as much voltage as the lemon. Here's a graph of the averages of my data. Ladies and gentlemen, we have a winner, the lemon! And in second place, the apple. In third place, the kiwi. And in fourth place, the poor orange. The lemon and the apple had the same averages, however the lemon was most consistent. Therefore, I placed it as first. All jokes aside, how does this process work? It is stressed that the fruit is not what produces electricity, but more the chemical reaction between the copper and the zinc, or the zinc itself. Electrochemical cells need to have an electrolyte, the citric acid, and 2 electrodes, the copper and the zinc. One electrode has to have a higher electronegativity. The copper acts as the cathode, as it gains electrons, while the zinc acts as the anode, as it gives up electrons. The anode of the zinc doesn't just lose electrons, it loses protons as well. Those protons need to move to an ionic solution, likewise to citric acid. Zinc oxidizes when exposed to the citric acid, meaning that the electrons from the zinc. The zinc is then positively charged and moved into the solution. The resulting electrons build up in the metal and rush through the wire and into the copper wire. The electrons in the copper pull out hydrogen ions and add electrons, resulting in hydrogen gas. Also, as mentioned before, lemon juice holds citric acid. When dissolved in water, acid breaks into charged anions and cations. Charged particles can flow through acid.